NASA chooses sites for lunar bases, but there's a big problem with China. First, a small postponement, then a second, then the news of something to be revised in the propulsion system of the Space Launch System rocket. And immediately there was controversy and innuendo about the inability of today's NASA to repeat the feats achieved by Apollo-era NASA. Of course, these were completely wrong compulsive reactions. It's not fair to think that because we went to the moon over half a century ago, it should be even easier today. Nor is it fair to think that the culture of rocket building has been lost. On the contrary, the Space Launch System has been shown to have problems with the engines, which are the revamped and modified versions of those of the Space Shuttle. But this does not mean that the engines are obsolete and that NASA wanted to economize on innovation. In fact, it was rightly planned to take advantage of the positive experiences of the more than 100 shuttle missions, exactly as they did at NASA for the Gemini, Mercury, and Apollo space programs, which exploited some of the far less positive experiences of the Atlas and Redstone launchers, which were created to carry nuclear devices. The point is that compared to the old launchers, the Space Launch System is much more efficient, meaning that its ability to carry heavy loads is greater than its total weight, a detail that reveals how all components must be lighter than those made in the past, which then have to be tested and experimented to aerospace industry standards. Safety comes from reliability, and there hasn't been any reliability considering that this is only the first launch. In half a century, the materials used for construction have evolved, but those known in nature and the special alloys that can withstand the more than 3,500 degrees Celsius that are reached in the combustion chambers without melting or expanding too much are rare. It's enough for the fuel to heat up by a few tens of degrees for it to begin to turn gaseous again, causing a disaster. And it happened that during the first attempt at the end of August, engine number 3 was not perfectly cooled. NASA's data said it was only 30 degrees short of the expected minus 230 degrees Celsius, but no launch director would have been crazy enough to authorize the launch with such a warning in progress. It was only discovered later that the temperature was correct and it was the sensor measuring it that was defective. In the September 2nd attempt, on the other hand, the malfunction was in the quick-release device on the cooling line, one of those tubes that we see coming off the rocket as soon as it starts to climb. NASA is now targeting September 23rd to retry the launch, or the 27th of the same month. All very annoying, no doubt, but never fear. Sooner or later, the mission will get off the ground. The really important news of the last few days, however, is something else. NASA has finally decided to officially declare what the 13 possible lunar landing zones will be for the Artemis 3 mission, the first intended to return a human crew to the lunar surface. We're going to the lunar South Pole, it's decided by now, but apparently the difficulties Project Artemis is facing will not only be technical. Let's try to see it through. This time, it will not be the great lava plains of the lunar seas that will see the landing of more humans on the surface of the moon. But as we are about to learn, astronauts will have to descend into the troubled regions of the South Pole, where the length of night and day is not marked by the rotation of the moon, but by the orography of the region and the contours and depth of craters, and it will all be much more complicated. But then, why choose the lunar South Pole? Well, for a very simple reason. In the inner solar system, water will be one of the most valuable resources that explorers can get their hands on. That's because you can use it in so many ways. You can drink it, of course, or use it to grow plant products. You can split it into hydrogen and oxygen, and then use the oxygen to breathe, and the hydrogen as a fuel for your rockets. You can even use the water itself as a propellant for one of those steam-powered rockets that are being experimented with right now. Water is also a fantastic shield against radiation. The surface of the moon is exposed to the dangerous charged particles of the solar wind and galactic cosmic radiation, but you only need to hide under a meter of water ice to be completely safe. But one thing is certain, in the inner solar system, water is a very rare resource, made almost unattainable by the proximity of our star's heat radiation. In recent decades, however, robotic exploration has allowed us to discover that on the Moon and Mars, and even on Mercury, there are regions, those in the vicinity of their respective poles, that may have protected water from the sun's heat. But apart from Mercury and Mars, which we will deal with in a few years, it's now our satellite that interests us most closely, since we are about to return to it, and is therefore absolutely necessary to land and set up the first bases in areas that can ensure a large amount of this fundamental element. Almost every part of the Moon is constantly bathed in sunlight or shrouded in darkness. During the lunar day, temperatures reach 120 degrees Celsius, and then during the night they drop to minus 232 degrees Celsius. In other words, during the day, any ice deposits exposed to light would be destined to sublimate in a few hours. But at the south pole of the Moon, sunlight strikes at a low angle. If you are at the Moon's south pole, you would see the sun on the horizon casting long shadows on the Moon's surface, and there would be craters around you where sunlight never reaches the bottom, regions where there might be ice deposits hundreds of millions of years old. So on August 19th, NASA finally settled on making public its selection of the areas best suited to support the first colonizing wave of the Moon. All 13 regions lie within 6 degrees, a little over 170 kilometers of the South Pole, far closer to the pole than any missions in the past. The bulk of the Apollo landings, in fact, happened near the lunar equator, and even more recent robotic landings have stuck to easier-to-reach regions. Each region measures approximately 15 by 15 kilometers, and within this area, 10 specific landing sites will subsequently be identified, each no larger than a circle with a radius of 100 meters. The pole yields a much different scene than the classic images of Apollo landing sites. While Armstrong and Aldrin bounced across the Sea of Tranquility bathed in sunlight from the Moon's 2-week days, the poles are a comparative chiaroscuro. Near the poles, the light varies from perpetual darkness to eternal sunlight, sometimes varying over distances of just hundreds of meters. That contrast is a big part of why Artemis is headed to the South Pole. Finding greater than average light will provide ready solar energy and stable temperatures, and finding permanent darkness will help uncover the volatiles gas, especially lunar water, that have not been stripped away by billions of years of solar wind. Hang on a sec, guys, before we continue. Be sure to join the Insane Curiosity channel. Click on the bell. You will help us to make products of even higher quality. Okay, let's not waste any more time. The sites are at Amundsen Crater, 2 sites along the rim of Nobile Crater, Leibniz Beta Plateau, the rim of Haworth Crater, and the rim of the crater Faustini. There are also 2 spots along the rim of de Gerlache Crater, which contains perpetual darkness, and at the de Gerlache Kocher Massif, a mountain located within the crater, along with 2 sites on a ridge connecting the de Gerlache Crater with Shackleton Crater. Another site is on a peak near Shackleton Crater itself, within which the Moon's south pole is located. Malapert Massif, a peak of eternal light that is constantly illuminated by the sun because it looms over the pole's lunar horizon, is the final site. These regions are going to be challenging technically for both Artemis 3's Starship and astronauts. Because the sun rises much lower in the lunar sky as you get closer to the poles, there are going to be serious difficulties planning missions to spots that are only intermittently lit. The Apollo missions, which landed in the Moon's equatorial region, could count on 2 weeks of sunlight followed by 2 weeks of darkness. But sites near the poles, where shadows cast from craters and mountains can shorten the expected day down to less than a week, will offer a much tighter window for a mission to land, set up, do science, and lift off. In addition to the proximity to possible ice deposits, the choice was also dictated by the way the site is illuminated and the ease with which astronauts will be able to communicate with Earth. Radio waves do not exceed the curvature of the celestial body, even without the radio link offered by an orbiting module, somewhat as was the case during the Apollo missions. It must also be kept in mind that none of the 13 selected regions is constantly accessible, so it will be the launch date of the mission that will determine the choice of the region where astronauts can land. For given launch dates, however, you will always have 2 or more sites to choose from. There is, however, a complication, this time a political one. NASA's choice may in fact collide with the similar choice made in 2020 by China for the Chang'e 7 mission, also destined for the South Lunar Pole in 2024. In practice, both space agencies have chosen lunar landing sites that in most cases overlap. In the case of the two missions, Artemis 3 and Chang'e 7, the scientific and operational conditions are very similar. That is to look for an elevated spot with constant light and at the same time close to ice deposits, typically found in craters that are in the shadows. The 13 areas selected by NASA have a very large surface area, hundreds of square kilometers, unlike the 10 points chosen for the Chinese mission. But all the points chosen by China still fall within the 13 regions selected by NASA. What will happen next? As it is widely known, the two great powers are not going through a good period of communication. It is currently unclear whether, and if so, how the two nations can coordinate to avoid problems with scenarios where one mission steals the other's site by arriving first. The issue must also be addressed for the future of space exploration. In fact, both the Artemis and Chang'e programs, and then the Russian-Chinese program for the International Lunar Research Station, intended to lay the groundwork for permanent outposts in the lunar South Pole. Therefore, it is clear that without dialogue, such conflicts could be much more frequent in the future. Artemis 3 will be the first manned NASA mission to arrive on the surface of the Moon since the end of the Apollo program. Currently scheduled for the end of 2025, the mission will bring 2 U.S. astronauts to touch down on the lunar surface, thanks to SpaceX's Starship, which will be deployed as a lander. The lesser-known Chang'e 7, on the other hand, is an ambitious robotic mission that is part of the third phase of the Chang'e program. That is, those missions dedicated to the study and exploitation of lunar resources and the construction of a robotic base, preparatory to Chinese human missions at the end of the decade. Chang'e 7 consists of several elements including a lander, a rover, and an orbital part consisting of an orbiter and a small communication satellite, all for a mass of more than 8 tons. It should be launched in mid-2024. The problem, while not one of the simultaneous missions, could be contamination. The U.S. will also not be able to agree with China because of a law known as the Wolf Amendment, a 2011 clause introduced by then government representative Frank Wolf that severely limits NASA's ability to collaborate with China in any capacity. This could be the first potential point of conflict over resources beyond Earth, said space policy and legal professor Christopher Newman. It will be interesting to see what happens, but a lot will depend on who gets there first. It's a sad story. This is certainly not a good way to begin what was supposed to be peaceful colonization of our solar system. What do you guys think?